Okay. All right. Major keys. Major keys. You ready? First up, you have to be able to graph. Your graphing skills are going to be critical. They'll stop you right in the beginning of the problem if you can't graph not an exact graph, but if you can't sketch a good graph in the very beginning of a problem, then that's going to cause the rest of the problem to be off as well. We're going to go through some example problems from last year's final exam, from last year's midterms. I take the problems right out of there and show you exactly where those students needed those skills. Secondly, you have to be able to, we kind of talked about limits last time, but we did an integral question. So we're going to do a couple just one Lhopitals Rule question. So your ability to be able to find limits using Lhopitals Rule is going to be critical. And then it's just derivatives and integrals. So we have to be able to take the multiple derivatives of every function, not to take the derivative of an arc sine, be able to deal with the chain rule, be able to take 2, 3 derivatives. And then finally, the ability to integrate, but not with the techniques that we're going to learn in this class. Before going into 104, you need to be able to being able to find the antiderivative, being able to use the substitution. All of these will be critical. They'll be in the middle, or sometimes in the beginning, or sometimes at the end of the problem. It won't be the entire problem, but some of these will be, multiple parts of these guys will be involved. So you want to be able to know how to do these things well before going in. And then lastly, the last key is that you just can't give up. Okay, it's gonna be difficult, very difficult. You have to be able to grind in this class. This is the most difficult class I think we have because of the material that's covered, and the speed and sort of the depth of the sections that we have to cover. And so those are the major keys to being ready. But if you find yourself lacking in any of these areas, please just go to 103, Google Remember 103 and find my notes. So you want to do that this weekend, because on Wednesday we start right away with the new material. If you're lacking in multiple areas, then you really want to do some work this weekend. Take advantage of the 3-day weekend. And so those are the major keys, but the key is to have every key. Okay, so let's start. Graph the region bounded by y equals 1 over the square root of x squared minus 1. Y equals 0, x equals 1, and x equals root 5. This was a problem from the final exam, given last semester, I believe. Yeah. And so right in the beginning, this wasn't the problem, of course. This was the beginning part of the problem. And then what we do with this region is we revolve it around some axis, and then we go find the volume. And we'll be doing that starting next week. And so it's our job to be able to get a good version of the graph, because that'll help us figure out which technique to use when doing the volume. And so we have to be able to graph. Can I click on this? Oh, no, I can't. Okay, hold on one second. Let me click on that. No? Ah. Can I go to the hyperlink? Gosh. All right, I got this. Oh, no? No? What? All right. If you go to our notes page, there's a list of functions that you should know how to graph. Graphs you should know. Click on that. You know, be able to graph a line. Be able to graph a parabola that's sideways, a square root, x cubed, a cube root, e to the x, log x, sine, cosine, and tangent, pretty much, those three. 1 over x, absolute value of x, arctan of x. Know those standard graphs, and then know how those graphs can be transformed by adding and subtracting, or by multiplying by a particular number. So that's in our notes page, graphs you should know. And so that when you're faced with something that you don't know, you can then be able to start someplace and then shift. That seems to be what we have here. We're looking at 1 over the square root of x squared minus 1. And so we have to be able to graph that, know what it looks like between 1 and 5, essentially. And so if you think about the minus 1 not being there, what does this function then become? 1 over x. Okay, great. And so what you have to do is think about, well, what happens when I take a normal function f of x and alter it in certain ways? And so I'm going to take f of x and multiply it by a and shift x by b and then add on some c at the end. alterations on a normal graph. So our normal graph is going to be pretty much 1 over x, and it's been altered in some way. We just want to get a sketch. It's just a sketch. It's not really a precise thing, but you want to be able to sketch it. And so the a, what does the a do to the graph of a normal, one of those guys who were on the list there? What would multiplying it by a do to the graph? Say it again. It would stretch it based on the value of a. Very good. So this affects it by stretching the graph. It could also shrink the graph, compress it. Let's use the word compress. It can stretch it. It can compress it. What else can it do? The value of a. What if a is negative? We reflect it across the x-axis. So all of this can be done by multiplying by a certain number a, okay, reflect across the x-axis. All right, sounds good. What about this b? What does this b do? Inside with the x. That's not exactly what we have here. It is an x minus 1 quantity squared, but anyway, x minus b. What does this minus do? If it's a minus, if it's a plus, it does something different. For example, what does y equal x minus 4 quantity squared look like? What is the effect of the parabola? What happens to a normal parabola when you put a minus 4 in there with the x? Does it alter it in which way? Shift to the left or to the right? To the right. Very good. So b will affect a x direction shift. Okay, good. Either left or right. Sounds good. And then we have lastly the c. Plus c is going to do what? Up or down. So if it's positive, it's going to shift up. If it's positive, the graph is basically going to go up. And then if it's negative, it's going to go down in the deal. Ready? All right, so that's what we're looking at. 1 over x. What does it look like? For positive x, we only care about x from 1 to 5. 1 over x. When x is small, what happens to 1 over x? It's big. When x is large, what happens to 1 over x? Small. Okay, so just draw something that kind of does that. Okay. The minus 1, though, changes things. Because 1 over x can't be evaluated at 0. What x can we not evaluate at for this one? 1. If x is 1, why is that bad? It'll be division by 0. When you have division by 0, what you have is a vertical asymptote. Okay? As you approach 1, we only care about approaching 1 from the right-hand side. It's going to go off to infinity. Okay? Great. So just draw something that does that. Stop when x is 5. Just mark it off. That x equals 5 is a vertical line. X equals 1 is a vertical line. And then y equals 0, what's that? More commonly known as the x-axis. Every point on the x-axis has y equals 0? Okay, so there's your region. All right. This is the first problem on the final exam, where we then wanted to take this and then reflect it, rotate it about, I believe this question was rotating about the y-axis and trying to find the volume of such a shape. Okay? And students couldn't graph it. And if you can't graph it, then it's going to hurt you in being able to choose the right method. There's methods to decide from disc, washer, shell, and if you don't have the right drawing, you won't be able to figure out which method to use. This next question was a part of a midterm, from my midterm I gave last semester, and the students had to graph the square with the vertices that are listed. I'm sorry, yes, go back to the other one. Okay, good catch. Thanks. When x is root 5, what's y? 1/4? 1/2? It's a fraction. Gotta be a little bit more precise. It is 1/2. You take the root 5 and you square it. You take away 1 and then you square root that. And you put that on the bottom. Okay. then it goes off to infinity as you go towards 1. I didn't mark off 1, but yeah, okay, good. All right, wonderful. So this is an innocent question. I was so surprised by how many students couldn't do this. Like at the very beginning, this is the first question on my first midterm I gave last semester. It was a volume question, but not a rotation volume. It was a cross-section volume question. And the students plotted the points. We could do that, right? So let's plot the points. We have 1, 0. That's great. And 0, 1. Wonderful. And then negative 1, 0. And then finally 0, negative 1. Innocent question. So here's where they went wrong. They drew a square. But these weren't the vertices of their square. They just said, oh, this guy here, right? There's my square. And it threw the whole problem off. You'd think it wouldn't, but, with volume being, just some kind of shift on it. But it did. It threw the whole problem off, and they were done right from the beginning of the first question on the first midterm. So what are you supposed to do? If the vertices of the square are those points, corners, vertices, okay? You connect them with lines. That's the square we're looking for. It is a square. What's the side length of the square? It's not 1. Root 2. Good job. This is 1, yes, and this is 1, and that's a root 2. All right. Sounds good. Let's move on. Enough of that. Can you do Lhopitals Rule? This is a question from final exam. Just gave. Less than a month ago. It wasn't exactly this question. It was a sequence question. But your ability to find the limit of a sequence reverts back to your ability to find the limit of a function. X is getting large, going to infinity, so x squared is getting large. So that's going to infinity. That part is. Don't think that the answer is automatically infinity, though. The other part is going to affect too. What is 1 over x as x gets large? We just answered that question. Small, it goes to 0. And what is the cosine of 0? And what is 1 minus 1? These things are at war with each other. One wants to be small, the other wants to be large, and it turns out the answer is neither one of them. It's something very different. It's a finite number. And we have to figure out how to do that. In order to do Lhopitals Rule, there's 2 forms. 0 over 0, air quotes. Infinity over infinity, air quotes. We don't have that. What we have is 0 times infinity. So that is an indeterminate product, but it can quickly be turned into an indeterminate fraction, where we can use Lhopitals Rule, turning a product into a fraction. Instead of multiplying, you can divide by the reciprocal. So instead of multiplying by, well, who's reciprocal? You want to use the 1 minus cosine? 1 over x is reciprocal? Or do you want to use x squared as reciprocal? X squared. You got to do the easiest route to it. So we're going to do 1 minus the cosine of 1 over x, and then divide that by the reciprocal, 1 over x squared. You didn't change it. You rearranged it. Okay? And now it's in L'Hopital ready form. This is 0 over 0. This was on their final. Took less than a month ago, this question. Okay. So what made it a 104 was that it was about a sequence. But it was really a 103 question. Okay? This is 0 over 0. L'Hopital ready. So how does L'Hopital Rule work? Okay, so we have to trade this in for another limit. We're going to use L'Hopital's Rule. Trade this in for another limit. The limit is still as x goes to infinity, and we take the derivative of the numerator divided by the derivative of the denominator. What's cosine's derivative? Negative sign. Now this negative is already there. So we're going to have positive sine of 1 over x, but since that's more than an x, can't stop there. Chain rule says keep going. Multiply by 1 over x's derivative, which is negative 1 over x squared. Its integral is natural log of x, but its derivative is negative 1 over x squared. All right? If your function is 1 over x, think of that as x to the negative 1, and you can use the power rule on it. Bring down the negative 1 and take x to the negative 2. That's called negative 1 over x squared. Okay, we want the derivative of it, not the integral. All right, sounds good. Negative 1 over x squared. There we go. Well, how about 1 over x squared's derivative? Negative 2 over x cubed. All right, good job. So it seems like it got worse. How did it get better? We can put these together and simplify basically as 1 over x squared divided by negative 2 over x cubed becomes, I guess they're both negative, so let's go ahead and just, well, let me write it down first. And so what's going to happen, it becomes x over 2 when all is said and done. But let's write it as 2 over x in the bottom. Because we end up at that same place. If we use x over 2, we're at that same place of 0 times infinity. And so here we go. We've simplified. You have to simplify along the way. So we've simplified. Uh-oh. That's not good. Uh-oh. More DJ Khaled to come. Okay, here we go. So here we are again. Sine of 1 over x. 1 over x goes to 0, and the sine of 0 is 0. And then 2 over x is also going to 0. Sometimes you have to do Lhopitals Rule a few times. Okay. But at this point, we'll be done. Maybe I can fit it in here. Let me erase some. I can't erase it because anyway, what is sine of 1 over x's derivative? Cosine 1 over x, negative 1 over x squared. Okay, 2 over x is derivative, negative 2 over x squared. Okay, these guys combine again to basically be a 2. But where? Is it in the denominator? Is it in the numerator? Where's that 2 at? Where are we at? Is it numerator or denominator? All right, we have to work it out. Okay, negative 1 over x squared times, don't worry, it's okay, negative x squared, I'm not mad, over 2. It's a half. It's in the denominator. Okay, so we're looking at cosine of 1 over x over 2. Okay, I wish I could erase some of this. Let me see. Maybe I'll just add another slide. Cosine of 1 over x over 2, x heads to infinity. We used Lhopitals Rule that last time. Oh, I did write that. Okay, good. And we end up with 1/2 is the answer. That was on the final. Okay, it was a 103 question, really, in the dressing of a 104 question. Go harder. We gotta work. This is on the final. In the dressing of a 104 question, you had to take 3 derivatives. 3. Okay? 3 derivatives. Seems innocent, right? But no, it's not at all. What's the first derivative? One over 1 plus sine x. Whenever you have the derivative of, or say you have a function that is the natural log of some other function, its derivative is 1 over that inside function, but then times the derivative of that inside function. You can put into one fraction for sure. That's what we're going to end up doing anyway after simplifying it. So it is 1 over 1 plus sine x, but then it's times the derivative of sine x, which is cosine x. So your first derivative is cosine x over 1 plus sine x. Great. So therefore, your second derivative requires you to do what technique to take it? Quotient rule. It's like a 4-letter word, right? All right, you can do it. You can do it. Take the denominator and square it. Take the denominator and bring it to the numerator. Take the derivative of the numerator. Sine, cosine derivative. Negative sine x. Put a minus sign. Leave the numerator alone. Take the derivative of the denominator, which is cosine x. All right. So you've done the first derivative. Okay, you know your chain rule. You've done the second derivative. You know your quotient rule. Now it's going to get deep. We have to simplify this. There's no way we're ready to take a third derivative. Okay? What do you recommend? What do you recommend? How are we going to, this numerator is a mess. Make it better. How? Yes? This guy is definitely called cosine squared. You want to do anything with this? Let's distribute. Okay. It's called negative sine x minus sine squared on x minus cosine squared on x. It's the thing about trig identities. You can go all over the place with them, right? There's no way of knowing what is the best way to go. Sine squared plus cosine squared is more commonly known as 1. What about negative sine squared minus cosine squared? Negative 1. This here is called negative 1. Good job. We are still not ready. Watch this. Something nice happens. Sine from above. Negative sine x, take away 1. That's your numerator. Both negative. Let's factor out a negative 1. We get 1 plus sine x. Hey. Why? Why is that hey? It's in the denominator. Cancel. This guy goes with one of those guys. Your job then is one more derivative, but you've simplified this so much, you've made that third derivative very easy to do. You don't even have to use the quotient rule. You could bring that up as a negative 1 exponent and use power chain rule. This was on the final. This is the last question. On the final. Less than a month ago. I'm not supposed to be saying that, but I am recording this, so I got to make sure. I'm careful who watches this. Are you ready? So bring down the 2, or it comes down as a negative 2 after multiplying by the negative 1. Take that guy to the negative 3, and then multiply by the derivative of that inside. So we have a negative 1, then we come down with a negative 2, then we have 1 plus sine x, and that goes to the negative 3. Just check and see if you're paying attention. And what's the derivative of the inside? Cosine x. Good job. And then they had to do something with it. I mean, it was a lot deeper than this. This was just a layer of the question. It simplifies to be, 2 cosine over 1 plus sine. All right, that's your answer. That's your third derivative. You don't like my 2? It wasn't a negative 2 to begin with? It was a negative 1? Oh, I'm with you. I'm sorry. That's a negative 1 there. Very good. See if you're paying attention. All right. So what happened there? It wasn't a negative 2. It was a negative 1. Let me change the color. Sorry. My attempt to see if you're paying attention went very badly. Let's try again. So we bring down this negative 1 with the negative 1 that's already there, and we take away 1 from it, so it becomes negative 2. Apologize about the confusion. And your answer then, the final answer, to what the third derivative is 1 over 1 plus sine x. Let's go ahead and call it cosine x over 1 plus sine x quantity squared. Are you okay with that? That's your answer to the question. To make it through the jungle, you're going to have to sweat. That was a sweat. Next question. The ability to derive any function. We got to take derivatives. So another layer. This was on my first midterm last semester. And this is part of the question. I gave 4 out of 10 points for this part of the question. It was exactly this. Later, after this was an arc length question, but half of it was a Math 103, take the derivative question. Most people actually, believe it or not, more than 50% of the class just ignored this part. They tried it, but you know what, I'm not doing this. And then they took it from there. You can't take it from here and then do the arc length question because it's telling you what the derivative is. But they had so much trouble trying to get this part that they just gave up. More than half the class. I'm not exaggerating at all. So let's take this derivative. There's two functions here. Okay? The square root of x minus x squared and the arc sine of root x. This is my first midterm, last fall. This was on there. Okay? So what's the first part of the derivative? What is this guy's derivative? Whenever you have any function that is the square root of another function, think about that as being to the half power, and then you bring that half power down to take the derivative, and then it goes to the negative 1/2 power, and then you multiply by the derivative of the inside. Ultimately, it's like 1 over 2 square roots of that same guy times the derivative of that guy. We should have 1 over 2 square roots of x minus x squared times the derivative of x minus x squared. 1 minus 2x. Right, that's half the battle. Here comes the other half. It's more difficult. Arc sine. Okay. So if your function is arc sine of some other function, your derivative then would be 1 over the square root of 1 minus that function squared. All that's underneath the root. Chain rule then times the derivative of that function. These are perfect things for a cheat sheet. These little tidbits on the side here. It's not enough just to write on your cheat sheet what arc sine derivative is. You should write a chain rule version of it. Because it's not going to be arc sine x on the exam. It's going to be arc sine root x. You knowing arc sine x's derivative is great. Yes, arc sine x's derivative is 1 over root 1 minus x squared. But it won't be so simple. It'll be more involved than that. So write the chain rule versions of all those derivatives on your cheat sheet. Okay? So we are going to have then 1 over the square root of 1 minus root x that gets squared, and then we multiply by root x's derivative, which we've seen pretty much is 1 over 2 root x. Okay. I am not trying to scare you, I'm just trying to let you know what last semester students had to do. Two functions, and then we took those two functions and we took their derivatives, and now it's our job to simplify. The calculus is over. Now it's our job to use algebra to make this simple as can be. Apparently, when we put these two parts together, we're supposed to end up with exactly what they have here. Doesn't look promising. Not at all. What are you going to do? Not much you could do to the first one. The first one is exactly 1 minus 2x over 2 root x minus x squared. Nothing you could do to that first one pretty much except for putting the 1 minus 2x in the numerator. Okay, so that part then becomes that. Okay, we have some work to do yet on this second part. Square the root x and get an x. And so then that's going to be simplified as root 1 minus x. And then we have a 2, and then we have a root x. These two can be combined into, not the both sides of the plus signs, but on this right-hand side we can combine these two. If we have a root of a and a root of b, we can make it the root of a times b. We can put that x inside with the 1 minus x and multiply it. And it ends up as the same denominator. Right? Root of 1 minus x times root of x is root of x minus x squared. So we have 1 minus 2x over 2 roots of x minus x squared, and then we have 1 over 2 roots of x minus x squared. Put them together in one fraction. It is 2 minus 2x all over 2 root of x minus x squared. Last step. Take out the 2. And then you're done. When you take out the 2, you'll have 1 minus x. It cancels with the 2 from the denominator, and you did it. 1 minus x over root x minus x squared. That was rough. Good job. It's not an easy road, but give thanks to the road. All right, let's integrate. Cosine cubed times sine. Don't be scared of trig. Don't let your weak trig background get in the way. You have aids, you have a cheat sheet that should have a unit circle on it. Know how to read the unit circle. Okay. This is a Math 103 question. It's not a 104 integration by parts question. It's not a trig powers question from 104. This is a U substitution question. What are you going to let U equal? If you let U equal the cosine of t, this part here is the cosine of t cubed. It would have been better if it was written like that. Then it would have been more obvious what to let U equal. You want to let U equal this inside function and see if its derivative is part of the outside. Not exactly all of the outside, but part of the outside. Okay. So the derivative of cosine is negative sine of t. What we're looking at for the rest of the substitution is the sine of t dt. So therefore we put a negative 1 times du to replace that sine of t dt. And then our integral just becomes u cubed times negative 1 du. U cubed times negative 1 du. You have to make a choice at this point whether you want to switch the limits or not. Totally up to you. Okay? I'm not advocating one way or the other, and you can go back and forth. You don't have to stick to one way. I'm going to show you how to switch the limits. The one thing you can't do, though, is you can't put those x numbers on this u integral. It's not true. Those are x numbers. I'm not going from x equals pi over 6 to x equals pi over 4. I'm on a u integral, so I need u numbers. I need to trade those x numbers in for u numbers. Just do a nice little chart here. Write those x numbers, pi over 4, pi over 6, and then write these u numbers by plugging into cosine. What is the cosine of pi over 4? Radical 2 over 2. Okay. Good job, good job. And the cosine of pi over 6? Which one? Root 3 over 2 or a half? Well, we have arguments. Come on. Come on, man. The cosine of pi over 6 is root 3 over 2. It's okay, you don't need to know it. You have a cheat sheet. But you should know it. We have an issue. Our upper limit is root 2 over 2. Our lower limit is root 3 over 2. What's the problem? The upper limit is lower than the higher limit. This is the danger you get in when you're doing switching limits. This might happen. And it's not obvious that it's happening. You got to know that root 3 is bigger than root 2. Okay? So this guy is smaller, and it's the upper limit. But you handle that by reversing them and putting a negative. To go with the negative that's already there. So in the end, you're just integrating u cubed from root 3 over 2 to root 2 over 2. It's u to the 4th over 4, and now it's your job to evaluate this by plugging in these numbers. You have to take root 3 over 2 to the 4th power. In fact, why not just pull the 1/4 out? Let me add a slide. Why not just pull the 1/4 out and have it as u to the 4th that you're dealing with, and then plug in root 3 over 2 and root 2 over 2. Okay, so what is root 3 over 2 to the 4th power? Root 3 to the 4th is a 9. Say 4 copies of root 3 is a 9. Okay, but then 2 is also to the 4th. So it's 9/16 minus how many 16ths? 4/16. I know that's a 4th, but leave it as 4/16. So you can easily combine it with the 9/16. But don't forget about the 1/4 on the outside, though. You get 5/16 times the 4th. Final answer, 5/64. So many places to make a mistake there. Not squaring, not taking the 2 to the 4th, messing up the root 3 to the 4th. Lots of places to make a mistake. Okay? All right, one more. This is a more traditional one with x's and not with trig involved. X squared plus 9 times x from 0 to 4. What are you going to let u equal? The inside. Because its derivative is not exactly the outside, but pretty much the outside. X squared plus 9's derivative is 2x. Okay, we put the dx on there, and we see that the rest of our substitution has to be x dx, so we take half. 1/2 of du is going to replace x dx. Okay, great. So we're going to have then 1/2, let's pull it all the way out, and then we have a square root of u, and then du. Let's do this without the limit switch, although limit switch is nice and easy with this one. Without the limit switch, just perform the antiderivative, find the indefinite, and then plug back in. So what is the integral of u to the half? What does that equal to? You raise it to the 3/2, and then divide by that 3/2. It is 2/3 u to the 3/2. Okay, it's u to the 3/2 over 3/2, but you multiply by 2/3 instead of dividing by 3/2. 2's cancel, so you have 1/3 of u to the 3/2. All of this, think about it as side work. You didn't know what the antiderivative is, but with that side work, you now know that this guy's antiderivative is 1/3 of x squared plus 9 to the 3/2. And now you're ready to plug in your 0 and your 4. So this is without the limit switch. Perform it in U. Don't put those x numbers on the U integral. Just ignore the numbers, ignore the limits, and keep going with it, and then trade back in what U is. Put a 4 in. 4 squared plus 9, that's convenient. What is 4 squared plus 9? It's 25. So we have to take 25 to the 3/2 power, and then we have to, now it's not 0. Don't ignore that lower limit. Most people think, oh, 0 is a lower limit. I don't have to plug it in. No, you do. 0 squared plus 9 is a 9. So you have to take 9 to the 3/2 and take it away from 25 to the 3/2. Having fractional exponents like that, don't let that bother you. When you have them, you should break it up into parts. Make it the 1/2 part first. Please don't make it the cube part first. You don't want to cube 25 first and then try to figure out what the square root is. You want to take the square root first and then cube. The square root of 25 is 5, so 5 cubed is 125. Okay? You wouldn't believe how many students would take 25 and multiply it by 25, get 625, and try to go again times another 25. You don't have a calculator. I would never ask you to do that. There's got to be a better way. Okay? And so here we have it. 125, take away, what's this guy then? 9 to the 3/2. It's 27. Okay. And so there we have it. 98. Does 3 go into 98? There's divisibility rules that you can use. If you take 9 and 8 and add together, you get 17. Since 3 doesn't go into 17, then 3 doesn't go into 98. Divisibility rules? What was that, 4th grade, 5th grade? All right. It's Friday, we're done. We had fun. You have to make it through the jungle to make it to paradise. That's the key. Lion. The other day the grass is brown. Now it's green. Because I ain't give up. Never surrender. When you stop making excuses and you work hard and go hard, you'll be very successful. They don't want you to win. They don't want you to eat. They don't want you to ride jet skis. Have a good weekend. Another one. Let me stop this recording. Maybe it was never recording anyway.